I'd like to introduce Todd Zabelle. He doesn't need much of an introduction. He's kind of the brainchild behind a lot of this, and we're really pleased that he's got some deep thinking to share with us here. If you haven't met Todd, he's the founder and president of Strategic Project Solutions and the founder of the Project Production Institute. Prior to SPS, he founded Pacific Contracting, which was recognized in the mid-90s for its use of various innovations, including lean construction and virtual design and construction. And over the past 2 decades, Todd's authored numerous papers on the topic of optimizing engineering, fabrication, and construction. And he's got some great insights and thoughts to share with us today. So Todd, I'll turn it over to you.
Okay, thank you, Gary. So we ponder the question, what type of production is construction? And we're going to take a little bit of a trip down a road that's not fully jointed, but hopefully there's some nuggets in here that you'll be able to take away. So starting off here, it seems that in our discussions and observations within the engineering and construction industry and its customers, owners are frustrated. There's a lot of talk amongst owners about we're going to move to a factory model, make this stuff off site, get it out of here. I've been told I'm not going to have the necessary labor to do the work that I need to do. We need to standardize, we need to modularize, we need to do something. And so what we've seen is a lot of discussion recently on this idea of factory models and build off site. I can't tell you how many times we hear we're going to adopt the factory model. It's a factory model. What we're doing is we've moved to a factory model. And as Gary asked earlier, what actually is a factory model and how do you go do a factory model of construction? I think so far today we've had a fair amount of insight into that topic. For others, they call it simply as modularization. We're going to go do build this job using modularization. And as probably not as bad as the software industry is, the construction industry likes to take words and twist them into things that fit what they want to describe. And I'm not certain modularization is necessarily a good word. So we're going to propose a little bit later that it really gets down to automation and where you do things. Okay. So much to the point where CII, Construction Industry Institute, has through, I believe it was research team 283, came out and with a report, and this is, I think, a version 2 of it, talking about the benefits of modularization. And it's interesting in the total installed cost graph, they say that it's going to cost you a little bit more money early on. But of course, as CII always does, in the end, modular is going to allow you to cost less. And hey, it might even go faster. So, who wouldn't want to do this? But I must say, I'm enamored with the Construction Industry Institute. We call it by the people for the people. When we ask major investors in capital infrastructure, what benefit are you getting from a cost and schedule perspective from modular, they simply say there is no benefit. We do that because we feel that we're working in a remote location. We don't have access to skilled labor, and that is our primary reason for doing it. We didn't ever think that we would get a cost and schedule benefit from that. But again, the sense of being a chance of being provocative, we'd be interested in seeing what data CI actually has that shows doing things as what they call modular is going to take less time and cost less. And basically, if you understand the fundamentals of project production management and operation science, you can see why that may not actually be the case. So because of all this activity, contractors see an opportunity, and many are hiring what we would call manufacturing production engineers. We have some on the line with us today, and their job is to figure out how do we industrialize what is currently going on. It's interesting to watch the manufacturing production engineers observe the guys, the project managers and engineers and vice versa, trying to figure out how to make all this work. But as Gary asked earlier, not only adding to it, what is a factory model, but does adopting a factory model and moving work off site solve the problem? And if the problem, obviously, we're saying is better performance in the form of less use of costs, less use of cash, lower costs, and more time. We're hearing from some of even the people on the line today, we see the time of the schedule compression. We're not necessarily seeing the cost. Again, hopefully at the end of this presentation, some of that will be vetted as to why that might not be the case. When we push back on what is a factory model, interestingly enough, a factory model to a lot of people that are involved in engineering and construction is just really standardization of products or the assets. And we're very fortunate to have a good friend of mine, Mark Reynolds, on, who is going to talk later. He's the CEO of Mace. I'd say it's probably one of the best construction management firms in the world. And Mark and I were involved with BAA 20 years ago, or 20 plus years ago, where BAA took a modular design to standard products, and there was the multi-story car park and the pier and so on and so forth. So, a lot of this is not new. People have been moving work off the construction site for a long time. I know one of the original movements was led by a guy that used to run McDonald's facilities in Europe, Richard Ogden, I believe, that started something called Build Offsite in the UK. And the objective was to get the lorries that were delivering materials into central London off the roads. Okay, again, it wasn't necessarily about cost, but it was about solving a different problem that probably assisted in. But for most people, a factory model really means we're going to have standard products or standard assets. Now, that's different than what we might call the adoption of advanced production thinking that we're going to continue to explore as this particular session goes on with all the speakers. Interestingly enough to me, though, and you just heard it, is the automotive industry that's fairly advanced is pushing for personalization through configuration. And I don't know if you've ever had the experience where you go to log on and you're just thinking that maybe you might consider buying a new car, and you start selecting all the buttons and you get fairly confused as to this one deletes that one but adds this one, and should I get this or not? And you're trying to figure this out, and it goes on and on and on. And the point there is they understand that they need to have personalization through configuration, and that the days of the Model T, you can have any color you want as long as it's your black, isn't going to work. The customers aren't going to buy that, right? So it's really interesting and very valuable to understand what they're doing, because they have standard platforms, they have bill of material and a bill of process that they're using to create pretty close to customizable products within reason. Okay, so the question really is, what type of production is construction? And it could be any type of production that we want to make it, but we've made it a very specific type of production. And I think these are some of the attributes that we might agree on. It's high cost, right? So we're talking about big stuff that's expensive. We're not making pens or paper. It's one-off, mostly custom products that are built to order using a highly skilled workforce. That skill uses flexible, simple tools. That's changing a little bit, but for the most part, there's still a lot of tool belts being worn out there. A lot of tinkering and rework. I got a little project going on in my house. I'm reminded of how the person who's doing the technical work is both an architect and an engineer from two leading universities. And boy, do these guys they are highly skilled. We get whatever tools we need, and the architect, engineer, and the craft guys are constantly tinkering and rework. And it's amazing to watch how they want to work, no matter how hard I try to get them to move a little bit further into where we might want to be. And then there's this thing about field measure then make. So it's always best to measure it in the field and then go make it. I need to buy a little bit of stone. And the stone guy, you know, he's convinced that unless I want to guarantee the measurements, which I'm willing to do, we better measure in the field. So what does all this really mean? It means that we're deeply rooted in craft production. Ed Pound this morning said at PPI, our research has indicated there's been no improvement in productivity since the turn of the last century. That shouldn't be surprising because we really haven't changed anything, and we're a craft-based industry, as let's say compared to what you just saw in the automotive sector. And we're organized and we operate as such. And so what does this mean? Again, some attributes, extreme amounts of fragmentation. There are endless disciplines and trades, especially in the building sector. Lots and lots of people need to be involved. I was talking to Gary earlier. He's going to go build a house. I said, you got to really watch those bathrooms and kitchens. Unbelievable amount of trades that move through there. Of course, there's lots of contractors that are involved. I mean, when you get into technology, energy, automotive, you're not talking about endless numbers of players that are involved, especially when you get into energy and automotive. Construction is just everybody on every corner has some interest, it seems, in doing something with construction. The business model is service-based versus delivering a product. Some of our speakers are going to talk about how they're looking at changing that a little bit after this presentation. It's based on cost plus profit equals price versus, let's say, a product-based industry where you start off with how much are they willing to pay and what do we need to give them, minus our cost equals our profit. All right. There's customer threats from the GC community, and so if I'm a subcontractor and I want to make a move and I want to break out and say, hey, I could take all this production capability I have, whether it's to deliver data centers because I'm a big electrical contractor, I'm a precast company, and I want to be able to deliver turnkey facilities. You always have somebody who's your middleman, the broker in between the owner and you, saying, well, I'm not going to give you any other projects if you do that. Performance measures are all about productivity factor, earned hours, so on and so forth. Gary alluded to what that might look like at somewhere like Ford, where and even Mutu talked about this idea of matching takt time and cycle time, the takt time being the demand, the cycle time being the response. Liability and risk, it's incredible, at least in the US and US based companies, how there's this complete avoidance of means and methods. The insurance companies and the attorneys that advise engineering companies and architectural companies tell them, you are not allowed, and owners, to deal around with means and methods. The process on how you do the work is the one that's fraught with all the risk. And it's just bizarre to think that you could design a precast building and not assume that you're not dictating the means and methods, right? If you say that the steel is going to be welded, you're dictating the means and methods. Lots of administration, focus on contracting and risk. I think everybody's their experience of that's involved in engineering construction. Processes and tools are designed to support craft-based work. Not a lot of precision. They don't use float in manufacturing. The takt time is 57 seconds. Cycle time needs to be 57 seconds. They don't say, hey, let's just make the takt time a minute 42, and let's shoot for a takt time of 37 seconds. But if it comes out of 4 minutes, that's cool too. We'll just submit a claim. And then all this, tying it back to Anil Seth, is that there's underlying mental models. People believe that there's a time-cost trade-off or an iron triangle, and there's a lot of confusion about fundamental production concepts. But all that being said, probably the simplest way to put it, and thanks to all you guys over the last 25 years that have been saying, how do you simplify it, how do you simplify it, how do you simplify it, we propose to you that project management focuses on what, who, and when. And if you think about how you prepare a contract, who does that contract go to? When do you need them to do it? And what exactly do you want them to do? And if you put together a schedule, you do the same thing. It says, here's what needs to be done by who, when. Okay. And so it's a whole world of what, who, and when. And what's missing is how and where. And so when we say there's a gap that Gary alluded to earlier, The gap is, how do we do the work? Yes, the means and methods, and where do we do the work? So a little different view of that might look like this, and where this whole debate is going on between factory models, modularization, offsite, is really between fabricating or making things, delivering them, and installing them. All right, that's where the action is. I think you could go back and you could argue that when they built the Empire State Building, the Golden Gate Bridge, U.S. Steel or whomever it was at the time actually was all the way over to the process. They were processing the material to make the steel upon which they were fabricating, upon which they delivered, they installed. All this has been fragmented out, and there's many players. Of course, there's people that make steel. There's people that fabricate steel to make steel members. There's another company that delivers it. There's people that erect it. And so many players in the value chain, if you will. And this little value chain is actually pretty interesting, because when you get to industrial construction, especially stuff around chemicals and oil and gas, et cetera, it is just basically one big massive steel value stream that is occurring, right? And so there could be very sophisticated valves or vessels or reactors, or it could just be a dumb piece of a structural member, but a lot of what's flowing through here is steel. So again, we've shown this probably many, many times, but really what we need to think about is that these 5 levers on how we design the product, whether again it's just a connection or it's a complete facility, how we design the work processes to create that, and you saw some of that DFMA, design for manufacturing assembly through MUTU, is really important. But it's also important to think about how we allocating our capacity and think about the contributors being labor, equipment, and space, the relationship with inventory, stocks, things that might be inbound raw materials or outbound finished goods, and most importantly, the WIP or work in process, and then finally the relationship with variability. I think most of the people on the line understand all this, so we're not going to spend too much time, but what we can say is inventory, which is not considered in project management anywhere in the methods and processes. Inventory is a proxy for time. So if you want to predict what might happen, if you want to know what's going to happen in the schedule, if you measure the inventory, specifically the work in process, you can actually predict how long it's going to take. All right. Again, we're not going to spend too much time on this. I think most people in this call are fairly advanced. And of course, there's these relationships or curves that we talk about that are very important to what we're doing here, especially with regard to industrialized production and its application to construction. The higher the utilization, the greater the cycle time. So, it doesn't make sense to have everybody working as hard as they can. And Gary alluded to that at Ford. If you increase variability, it gets worse. Throughput will eventually get maxed out no matter how much whip you throw at it. As a matter of fact, you might not only get less out, you might drive the cycle time up, and it might take longer to do that. In the meantime, you're significantly increasing costs and the use of cash because you believe that we could actually get more done if we put more in. And so again, on the manufacturing side, what we call industrialized construction, takt time is what is the demand. Cycle time is how fast can we produce. Those are the interesting measurements. You can't change the throughput and you can't change the cycle time. All right, so any of you guys that are playing around with the industrialization of production, throughput is a measurement, cycle time is a measurement. You cannot do anything with those other than look at them and read them. All that you can play with is utilization of the capacity, management of inventory, especially the WIP, and what you're doing with variability. Okay? Time is a function, and the throughput, the amount of stuff you get out of the system, is what you're doing around capacity utilization, WIP, and management of variability. All right, so what type of production is construction? Well, a construction project is actually I don't know what the word might be, but is a whole bunch of stuff that comes together, different types of production And a very useful tool for understanding this that you might want to take away is it's called the product process matrix, originally developed by Hayes and Wheelwright. And then Schmaner here added a project to the matrix. And so what the matrix is telling you is that there's different types of production. On the bottom right is continuous flow. So if you're involved in pharmaceutical goods, refining, you're probably very well versed in continuous flow type systems or production systems, if you will. And these things make, again, food, pharmaceuticals, and processed hydrocarbons, maybe chemicals, and so on and so forth. You have line flow, which is what Mutu was alluding to and what they're doing in automotive. It's in this first example here, it's machine pace, which means that the assembly line was not necessarily developed by Ford or invented, but was perfected by Ford, sets the pace as the work moves through the line. And then you can have a worker pace line flow. So when you see these videos of people in China that are all stacked up in these large production facilities, that would be more of a worker pace line flow. You have batch flow, where you put a bunch of stuff together and run it at once. You do call it a concrete batcher. And then you have a job shop. And so think about in a job shop, structural steel, okay? And then finally you have a project, which we might say that maybe a project sits on top of all this. And it's really about understanding what kind of production system is that particular supply chain or value stream that you're dealing with, all right? Now, for this presentation, we developed something that we thought might be interesting to you. And this was really to understand what are people actually trying to do out there. And so we put together a little spectrum here that says there is people that are trying to move work from on-site to off-site. There are people that are trying to move work from craft-based to automated, all right? And so what that might look like is these photographs here. Here we could clearly see craft-based on-site work. Somebody's working with their hands. They're installing some masonry units, brick, whatever the case may be. And now somebody's made a decision to move that kind of work off-site, and we see craft-based work in a warehouse off-site where somebody's looks to be assembling some walls or maybe a ceiling because it's a lighting fixture that's going in. But there's also a movement to automate on-site. And here we can see a robotic drilling machine that Hilti's just announced. So we have automation on site. Then we have, and this happens to be from Katera, so give proper notation to them. This is automated offsite production, all right? And so we're proposing to you that it is of value to understand what is it I'm actually trying to do. Am I trying to automate things, or am I trying to move things off-site? And you might be surprised on which one of these things is the most dangerous, if you will, to your financial health. And so we're looking to develop, and this is almost a piece of PPI research, if you will, a spectrum that puts more color on this that says, okay, there's on-site, then there's on-site within the site boundaries. Then we start moving to off-site where we're going over the road. Then we really go to off-site where we go overseas, okay? And so because we're production guys and we think a lot about variability, obviously the further we go to the off-site, the more risk we have of variability coming into the production system. The same could be true for the craft versus automated perspective, and that is we start off with hand tools, we move to power tools, then maybe we go to computer numerically controlled machinery tools, and then finally robotics, right? And so again, this is just trying to put a little bit more color on what this might look like. So what we're saying is which direction are you moving? And in hindsight, we probably should have put a poll on this, but and polled the audience. But where are we moving? Are we moving work off-site? We just want to get it out of here for some reason, and we'll still do it craft-based. Which, hey, if you've been in a lot of fabrication facilities, and I've been in a lot, really all that's happening there is just moving the same work off-site. Okay, are we again moving it? Are we keeping it on-site but we're automating it, or are we moving it off-site and automating it? And I like to talk about the gutter king. And the gutter king to me is interesting. And think about what the gutter king's doing. In this particular instance, Gutter Magic, LLC, if you will. Gutter Magic can pull up at your house, could measure how much gutter you need for your roof, can hand you an estimate or a quotation, you can approve it, and the gutter king can knock that thing out in a few hours, drive away, and go down the road. Now, there definitely is a question on what color the gutter king can provide, but that could probably be answered in advance. Hey, I'm going to be out there at 11 o'clock today. Is there a particular color that you're interested in? Right? But the gutter king's got a mobile factory here that allows them to very quickly and efficiently create stuff using what we might call automation on site to some extent, right? Now contrast this to someone who would have a shop, and even if they had a shop, they would have to go out field measure, create some kind of communication back to the people in the shop that are going to make the stuff, have it made, find a way to temporarily support it or short or whatever you want to do, ship it back out, and then put it in place. Okay. So I think there's something.
Todd, you're giving you a 4-minute call here.
Okay, perfect. So I think there's something there, and thinking through, if we go back, what the gutter king's doing and what this might all mean when we come back to this idea of modularization. All right. So clearly there's the opportunity of concurrency of work. You could be building things or making things while you're preparing the site. Okay. But you got to take into account that there's a cost of doing that. And there's a cost of inventory, which is you have to amass, handle, hold, preserve, and deal with damage, theft, meaning people are taking parts, not necessarily burglary, and then the threat of obsolescence. You also have to think about additional costs related to disassemble, reassemble, structural support, protection, and then the poor use of transport capacity. You're giving something up. And we can go all the way back to Ford, who said, look, I'm not going to ship the cars assembled, I'm going to ship the cars disassembled. All right. And what IKEA does with their flat packs, right? So again, I think what we're trying to communicate here is a word of caution to taking everything off site and attempting to fully automate things where that's not always the best practice. I'm going to go through a really quick presentation here in 2 minutes, and then I'm going to wrap it up, okay? So if we go back 20 years ago, and Mark, you'll appreciate this, to Heathrow Terminal 5, this was a project that actually the company was taken over by a guy that ran Jaguar in the UK, so it had a high volume perspective to how they want to deliver the project. But some interesting specs, if you will: delivery to site every 30 seconds, couldn't make any deliveries between site 7 to 9 and 4 and 6, single road, storage was 1 day or less, the majority of work occurred after 9/11, so there was all sorts of crazy stuff going on. But the design of the production system used 2 logistics centers to buffer upstream variability, to house material, and what we're able to do through using modern production, this is 20 years ago, was do the detailed engineering for the rebar in 3 days, the fabrication and assembly of cages in 2 days, and the delivery and installation in 2 days, with a total cycle time of 7 days, right? And that ability to go from 6 weeks down to 5 days, which was brought back up to 7 days, was all done in about a 2-hour planning period, okay, at looking at the production system. And really quick here, finally, we also use what Mutu alluded to, this concurrent digital engineering, to design the foundation, the piles, and the factory that was going to produce the piles all simultaneously, and found that there were some issues with the machines and their ability to actually do the job, which was rectified in advance, well before anything was bought or purchased. And to be able to get to that level of detailed engineering so fast, standards were set up as a platform, if you will, on the modularization as a design requirement for the structural steel, and then the fixers were brought in early using immersive reality to figure out, can we or can we not do that work? And so finally, again, here is offsite fabrication coming into a precast facility, and you can see there's old Greg looking for stuff, the rebar is all rusted out, and moving to a capacity-based model right, with a minimal amount of inbound materials, provide way more flexibility, a lot safer environment there. So, lots of interesting activity around automation offsite. This challenges current practice due to lack of understanding how and where we do the work. And we're proposing to you that PPM as foundation of operation sciences provides the needed framework. And with that, I will hand it back.